In this video I will show you how our universe looks if we zoom in many times and watch it in slow motion. I will show how its fundamental building block explain rationally all of its property, including the fundamental postulate, why the speed of light is constant, and why elementary particles have wavelength. This is not just my theory, but the true description of the universe. So if we zoom in many times, we will see that most of the space is filled with very thin plate-like particle, here in red. These plates, or spheroid, are very thin, almost two-dimensional. We will call them G particle. These G particles are moving with very velocity in any directions and in any orientation, but they are not rotated. If we continue to look in the universe, we will see that there are some bigger particles, here in blue and green, and they rotate very fast and in opposite direction, about one of their axes. If we will watch them for a while, we will notice that the green particle attract the blue particle, but that two green particles repel each other, or two blue particles also repel each other. If we will watch them, we will notice that they collide with the red particle and throw the red particle into each other. And this attraction and repulsion is just a collision result. This is a mathematical truth, and I was able to prove it mathematically. In other words, this is a pure truth. In my book Collision Truth, I have derived all the mathematics and all the mechanics from the only two definitions, the time and the space. Download this book from the description. In my book I have shown that all the laws that govern this collision, like conservation of momentum and conservation of energy, are just a mathematical truth and not a truth of nature. I will show you a short movie that demonstrates this attraction and repulsion mechanism. This short movie was created by the simulation that I built in MATLAB. The simulation MATLAB file is attached in the description also. You will be able to see that I have used very advanced mathematics from the last years in order to calculate the collision detection and the collision resolution. So let's watch. This movie was just an example, but I have run my simulation millions of times, and I have proved this principle beyond any doubt. More specifically, I have noticed there are some collision rules. I have noticed that the blue particle, that we will call E, when it collides with G particle, it produced usually and most predominantly a particle that's called GE here. This GE particle is just the G particle after the collision with E. It rotated in the opposite direction of E and faster, and it also translates very fast. By symmetry, the green particle that we will call E+, when it collides with G particle, it's transformed into GE+ particle, which rotate opposite to E+, and translates very fast. Here is the proof for rule number 1, which is this rule. In this table, each bordered rows represents different collision. What I did, as I took the E particle and collided with G particle that are located in different height and flying through this E particle. So in this table, A represents the E particle and B represents the G particle. W the angular velocity, V the velocity, translational velocity, and S the sizes. M is the mass, and dg is the position vector. So you can see that the angular velocity of B, which is g, transforms from 0 to 50,000 radian per second when it's collided with E particle, which is A, which has an angular velocity of minus 28,000 radian per second. So you can see that no matter from what height the g is flying through E, the E will transform the G particle into GE particle, usually and most predominantly, meaning that the most powerful particle that will formed is the GE particle with the faster angular velocity. Then I have noticed that GE particle and GE plus particle, when they collide with E or with E plus, they produce an attraction. The attraction mechanism is more complicated and it involves two steps. In the first step, the E plus particle create the GE plus, and the GE plus move into the E particle. Then it will throw the E particle to the right and also downward. Afterward, the next GE particle, GE plus particle that moving from E plus, will hit the E particle on the upper side, and then it will attract him. In this table, there are the GE plus particle in different height flying into the E particle. You can see when E particle is located upward to GE plus, in other words, the position vector dg in its two component of him is positive, then the E particle will have velocity downward, meaning that the bv, which is the velocity of B, which is E, is negative, so it will move downward. We can see that when GE plus particle hits the E particle, when the E particle is downward, it will attract him. In other words, the velocity of the E particle will be minus, and we can see it here. So this is the demonstration for the attraction. I have run millions of attraction simulation and proved this beyond any doubt. Read my book Spheroid Theory of Everything that is attached in the description. The last rule, number 3, is the repulsion rule. When GE particle, when it hits an E particle, no matter which height, it will repel him. This is more straightforward, and you can see from the table here that no matter what height the GE particle will hit the E particle, usually it will repel it. So with these 3 collision results, I have proved attraction and the repulsion. And I have shown that this is a mathematical truth or pure truth that depend only upon the definition of time and space, where time is just the quantity of seconds that passed. It's a one-dimensional quantity, and space is the quantity of meter in each direction, and it's a 3-dimensional quantity. If we continue to zoom in the universe, we will see that each E particle or blue particle is actually composed of many very thin particles, the G particle, which are lying in cluster very close to each other and rotate together. If we count them, we will see that there are 10 to the 24 G particles in each E particle, just lying very close to each other. And it's possible because G particle is very thin, almost a 2-dimensional. Same goes for E plus particle, the green one. We will notice that the green particle is what we call positron, and the blue particle is what we call the electron. And what we call charge is actually the angular velocity about the y-axis of this particle. Much as translational velocity is just what we call temperature. We can also understand the Coulomb formula, where Q, the charge, is just the number of electron or the number of positron. And it's reduced by r to the 2 because the charge is spreading. In other words, the GE particles that are flying are spreading in the 2-dimensional plate in the YZ plane and XZ plane. This attraction and repulsion is true no matter what's the position of the electron and the positron, because the G particles are flying in all directions in the universe and in any orientation. If we continue to zoom in, we will see that the E particle, the blue one, has angular velocity not only on the y-axis, which is the most predominant, but also along the x-axis and the z-axis. This angular velocity on the x and the z-axis are very, very small, and they are what we call spin. If the angular velocity along the x and z axis are positive, we will call this electron spin up. And if they are negative, we will call it electron spin down. And we color them in purple and in light blue. You can see these three lines represent three point of view. Because the spheroid is not a sphere and it looks like a plate, its rotation will have precession. In other words, its angular velocity vector will change in every time point. In the upper picture, we can see the motion of a spheroid that have angular velocity 3.1, 11, and 3, which is spin up electron. And in the lower pictures, we can see electron with angular velocity minus 3.1, 11, and minus 3. This is spin down electron. We will call spin down electron ED and spin up electron EU. In the picture, the green arrow represents the angular momentum that is not changed in any time point. The pink arrow are the angular velocity in work coordinate, and the red arrow are the vector along the axis of symmetry. The electron in the universe has a much bigger angular velocity component along the y-axis. So this picture represents the electron more close to reality, where the angular velocity along the y component is 110 and not 11. I will show you two movies. So because the electron spin up and electron spin down has angular velocity also along the x and z axis, in addition to the GE particle that they create, they also create another particle that are perpendicular to GE particle. Let's see it in three-dimensional. Here in green, we can see the positron that produce only one type of particle, GE plus particle. We can see it here, how it's produced because it collides with the G particle, the red one. The electron spin up, here in purple, collide with G particles and produce, in addition to the GE particle, which is this one, also these two particles, which we will call GN and GS particle. These GS and GN particles are perpendicular to GE particle. You can see it from the picture clearly. And they represent the magnetic field, while GE particle and GP particle or GE plus particle represent the electric field. Because of the precessional motion, the electron create mostly GE particle and very, very few GN and GS particle. So we already have many particles, so let's make a quick summary. These three lines represent three different point of view of the same particle. The electron spin up is EU1, electron spin down is ED2, the electron is the blue, and it's not exist actually, it's just an idealized particle. EU1 and ED2 look like E because the rotation about the X and the Z axis is very, very small. E plus is the positron, Gn and Gs are the magnetic field, Gp and Ge are the electric field. The angular velocity about the y-axis is what we call charge, and the angular velocity about the x and z-axis is what we call spin. Because these particles are rotated very fast, their angular momentum is preserved. So they will preserve their orientation in space. In my book Collision True, I have shown that conservation of angular momentum is also a mathematical law, mathematical truth, and not a law of nature. Because G is not rotated, it can be in the universe in any orientation. And it's the most common particle in the universe. We will continue to explore the universe with this theory, but you can already see that this theory lies on only three postulates: space, time, and the spheroid. Spheroid is almost a two-dimensional, time is one-dimensional, and space is three-dimensional. In the early universe, many positrons collide to each other, and their collision, if it was at the end of the particle in its edge, they inserted a little bit into each other and combine into a not stable form, which is here. This not stable form is not stable because this formed particle is rotated about the intermediate axis. In other words, when a particle rotates about its small axis or about its big axis, its rotation is stable. But when it rotates about its intermediate axis, its rotation is unstable. I will show two videos that...
And this is dealing with rotating bodies. And here I've got one of my engineering book, and I gave it an axial rotation. And about the long axis here, it spins nice and stable, as you can see. And about rotating in plane of the book, it also spins nice and stable.
At the short axis.
And both of these axes represent the maximum and the minimum moment of inertia. But there's another axis you can spin the book around.
Intermediate axis.
Like this one. And it's an intermediate moment of inertia. And it's not spinning stably. It wants to oscillate back and forth in terms of the rotation that it makes.
The instability of the intermediate axis is a mathematical truth. I proved it in my book Collision True. So when this unstable particle formed, when it collides with G particle in the universe, it gradually transforms into the stable form we see here. And when more and more collision like this accumulate, the proton will form. So a proton is just a cluster of 1836 positrons. In my book I have proved mathematically that the angular velocity of the formed proton is equal to the angular velocity of the electron, but only opposite in direction. Therefore, the proton will transform the G particle predominantly into Gp particle, which is equal to the Ge plus particle. And thus it will attract the electron and two protons will repel each other. Two protons collide with each other at the edge, they will insert it a little bit into each other and create a big nucleus. This nucleus can grow and grow when more and more protons continue to collide on its edge and insert it a little bit into it. If electrons collide with proton at the edge, they will also insert it a little bit into each other, but because they have opposite angular velocity, the total angular velocity along the y component will be cancelled and will be zero. But they will still have angular velocity along the x and z axis. Therefore, the formed particle, which we call neutron, will have spin also. This process is called electron captured, and it's happened in the nucleus. By this mechanism, the nucleus can become bigger and bigger, When the nucleus will have more than 26 protons, its rotation will be very close to a rotation about an intermediate axis, and therefore it will be not stable, and it can break apart with a process that we called spontaneous fission into two small nucleus. It can also emit alpha particle, which is He nucleus. This little insertion of particles into each other and their mutual rotation is what holds them together, and what we call a strong force. In order to explain how same charged particles hold together in tiny space, the proton and the nucleus also have very tiny angular velocity about the x and z axis, and therefore spin. So this is how an hydrogen atom looks like. We can see the proton in green and the electron in purple, which is now electron spin up, but it also can be electron spin down. This electron produces mainly Ge particle, and the proton produces mainly Gp particle. But they also produce magnetic field particle, Gn and Gs. The magnetic field from the nucleus is very weak. In other words, the nucleus will create very few magnetic field particles, Gn and Gs type particles. This is how an helium atom looks like. It has two electrons, one spin up and one spin down, and nucleus with two protons and two neutrons in yellow. Its two electrons will stand in front of each other and transmit magnetic particles into each other, so they will be paired electron. Let's see it in three-dimensional. The total magnetic field of the helium atom is zero, because the magnetic field of these two electrons will cancel each other out, and the magnetic field of the nucleus is very weak. But other atoms like iron can have unequal number of electron spin up and electron spin down, and we will call them magnets. We can separate magnetic poles because each electron produces a north and south pole, because it's precise and each side will see different rotation, one clockwise and the other anti-clockwise. This pole will be strongest perpendicular to the precession angle. If we rotate the magnet, the angular velocity along the y component, which is the strongest, will preserve in space, but the angular velocity along the x and z axis will change, so the spin will change. A moving charge creates magnetic field, because in addition to the heat that the E particle or the E plus particle produced by the angular velocity along the y component, it also pushes them. So they will rotate sometime perpendicular to the Ge or to the electric field particle and produce magnetic field. We can see from the 3D picture that opposite moving charges will produce magnetic field opposite in direction. And opposite charges also will produce magnetic field opposite in direction. We see the electric and the magnetic field, how they produced by the push of the electrons. Or the positron. What we call light is G particle that has angular velocity in addition to the angular velocity along the y component, which is the strongest, angular velocity along the x and z component, which causes it to precess. It can only form when the E particle or the electron accelerate, and because the G particle is not a perfectly smooth spheroid. We can prove mathematically that the angular velocity along the z component is preserved in all time point, and it's constant, therefore. What we call photon frequency is the angular velocity along the z component divided by 2 pi. Because the light particle or photon precess, the angular velocity change for every time point. In some time point, it's more in the direction of the angular velocity of the electric field particle, and in other time point, it's more in the direction of the angular velocity along the magnetic field component. When one is at maximum or minimum, the other one is at zero. Because the photon created by an accelerated electron, its angular velocity along the y component is the strongest, and it's mostly in the direction of the electric field. In the direction of the magnetic field is c-fold smaller, where c is the speed of light. So it's mostly in the direction of the electric field. Two photons are at phase if their electric fields are at maximum at the same time point. The bigger the angular velocity along the z component, the more space the photon will occupy due to its precession. If the photon angular momentum is in the direction of the translational velocity, we will say that this is circular polarized light. If the photon angular momentum is perpendicular to its translational velocity, we will say that this is linearly polarized light. And in any other cases, we will say that this is elliptically polarized light. The speed of light is constant regardless the light source movement or the observer movement, because this is the measured speed of light. The actual speed of light is much higher than c. But many photons have to be emitted in order to clean the path to the detector from the disturbing g, so a photon can reach the detector. Because if the photon will collide with g along the pathway to the detector, it will not reach the detector. Let's define delta t as the cleaning time for unit length. We can see that it's a function of the g particle density, the g particle average velocity, and the angular velocity of the electron. Therefore, it will be constant in the universe. And therefore, the measured velocity will be the distance to the detector divided by delta t times the distance. So it will be 1 over delta t, which is also constant. So we can calculate the time that take for an accelerated electron to produce photons that will clean 1 meter of length from disturbing g along the pathway to be 3 times 10 to the minus 9 seconds. If we will move the light source, in other words, if we will move the accelerated electron, it will push the g and create photon with higher frequency if it moves toward the detector, or lower frequency if it moves away from the detector. So we will see the photon as blue or red shifted. The actual velocity of this photon will also change, but the measured velocity will be constant, because the time to clean all the disturbing g will be constant. As it depends on the density of the g particle, the average velocity of the g particle, and the angular velocity of the electron. If we shoot a high frequency photon at a nucleus, it can break part of it and produce electron and positron. Because they produce at the same time and point in space, they will send many magnetic field particles into each other, and the path between them will be clean and remain clean. So even they will be farther away from each other, the g particle that going between them will travel at the actual velocity, which is higher than c. Therefore, if we will change the spin of one of them, the effect to the other will be immediately faster than light. And they are what we call entangled particles. When a charge is stationary, in other words, when it's not moving, the electric field will be reduced by r squared, because the electric field particle will be spread in the horizontal plane and also in the vertical plane. But when a charge is accelerated along the vertical plane, the electric field that it produces, which is light, will be reduced only by 1 over r and not 1 over r squared, because this particle will be spread only in the horizontal plane. In the vertical plane, we can see in this picture that when the charge accelerates, the detector A and detector B will see the same number of electric field particles, because they produced in every time point of the movement. But when the charge is stationary, the farther detector will see less electric field particle, because it's spreading in this plane also. If we shoot two photons one after each other, we will say that they are causing destructive interference if the first one hits the detector in the right side and the other one hit the detector in the left side of the electron. They are moving right one after the other, but the first one and the second one are precessing in different initial angular velocity. If the time point of the initial angular velocity of these two photons is coordinated with their distance, so when they travel and reach the detector, the first one will hit it in the right side and the second one will hit it also in the right side, and they will create what we say constructive interference, because the effect of the electron will be doubled, and in destructive interference the effect of the electron will be cancelled out. When an electron and positron collide exactly at the edge of them, they will be inserted a little bit into each other, and all the G particles that comprise them will be thrown to all directions. One of them will get angular velocity, and it will be the light with very high frequency, so they will annihilate each other. The electron and the proton spin are produced by the following mechanism. When the electron and the proton attract each other, they will never stand perfectly in front of each other by chance. So the GP particle emitted from the proton will also rotate the electron along its x-axis or its z-axis, or both, depending on the collision point, and depending if the electron is vertical or horizontal at the time of collision. If the GP particle rotates the electron about its x-axis, it will be much harder for the next GP particle to rotate this electron about its z-axis. And if the first GP will rotate this electron about its z-axis, it will be much harder for the next GP to rotate this electron about its x-axis. So in each atom, different electrons will have different spin, but they will have the same spin magnitude. When the GP or GE particle, which are the electric field particle or the magnetic field particle, will hit the electron, sometimes they will enforce its rotation, but sometimes they will decrease its rotation. So overall, the electron internal energy, which is its rotational energy, will be constant. Because the atom is symmetric, each electron can be spin up or spin down, meaning it can be in one side of the proton or in the other side, but in the same distance from the center. So the spin direction will be opposite. Different electrons in this atom will have different rotation about the x and z axis and therefore different spin. But for each electron, there will be place for its paired electron, which is in the other side of the proton, which will have the same spin with opposite direction. In silver atom, there is only one electron that is separate. The other 46 electrons come in pairs, so there are 23 pairs of paired electrons. The magnetic field that this paired electron is cancel each other out, but the magnetic field of this separate electron will not cancel it, and it will determine the magnetic field of the whole atom. This specific electron can be up or down. In other words, it can be in one side of the proton or in the other side, with the same angular velocity along the x and z component, but opposite direction. So if we shoot these atoms through an inhomogenized magnetic field, they will produce two spots. This is the Stern-Gerlach experiment. Inhomogenized magnetic field meaning that the number of the Gn particle is different from the number of the Gs particle. The nucleus also has spin, and it can also be up or down for each atom. So if we fire the nucleus through this inhomogenized magnetic field, we will also get only two separate spots. If we put a separate electron in external magnetic field that is in specific direction, the direction of the electron spin will also change to this direction of the magnetic field. This is because the Gn and Gs particle emitted from the magnetic field will change the electron spin to the direction of the electron spin that creates them. The more different the spin direction of the electron and this magnetic field, the greater the chance that at the collision, this particle will hit the electron not in phase. In other words, not face to face. This in-phase collision will transform the magnetic field particle into a light, because it will cause him to precess. So the more the electron spin direction and the magnetic field direction are different, the more the chance that a photon will be emitted. These pictures are other viewpoint of the same former pictures. Heated or beated magnet destroyed because in heated or beated magnet, the atom move very fast and the electron collide, so they change their position. And if the electron move from the upper side of the nucleus to the other side of the nucleus, it will change its spin direction. And because this process is random, over time, the free electron in the magnet will stop to point in one direction. Magnetic atom can align a neighbor magnetic atom to be in the same magnetic direction. It happened because the magnetic field particle emitted from one atom, when they hit another electron in the other atom, they will change its directional spin to be in the directional spin of the electrons that create them. The Earth has a magnetic field because in its core it has many iron atoms, and each iron atom has four free electrons that can point in the same direction and will make him a very strong magnet. The Earth's magnetic field can flip every 500,000 years because the magnetic core is very hot, so the atom move very fast and the electron collide and move from one side to the other. And when the electron move from one side to the other, it will change its spin. And when the 4 electrons in the atom of the iron will share their spin direction, their magnetic field direction will point in the other direction. And it can influence the neighbor atoms and start a chain reaction that will flip the whole magnetic field of Earth. The magnetic field will be flipped and not change to any direction because most of the atoms are already aligned to a specific direction and the nucleus also. Therefore, for the free electron, there will be preferred only up or down specific location. This preference is due to the symmetry of the atom. If a neutron slides from the nucleus, gradually, a piece of it may slide completely and hit it by the nucleus. This piece is the emitted electron, and because the angular momentum is preserved, the remaining neutron will be effectively become a proton. This process is what we call beta emission. And because the nucleus also has spin, in other words, the nucleus has also angular velocity along the x and the z component, it is more likely that the electron will be emitted mostly from one side of the nucleus. A process like this that changes neutron to proton is what we call weak force. Because beta emission is preferentially in the direction opposite to the nuclear spin, it's a violation of the conservation of parity, which means that mirror image particle will act differently. In the process of beta emission, 2 photons and 1 antineutrino also emitted. These are just broken pieces of the neutron. In other words, just G particle and G clusters that broke from the neutron. Rule 11. If the energy of 2 photons equal, their frequency is also equal. The reason for this lies in the structure of the G particle. When accelerated electron collide with G, it will give him a big angular velocity along the y component, but also small angular velocity along the x and the z component. The angular velocity along the z component is a rotation about the G symmetry axis. And the reason that it's created, it's because G is not a perfectly smooth spheroid. So there will be need a huge force to create this angular velocity along the z component. And there will be a strong connection between the angular velocity along the z component to the angular velocity along the x and the y component, and to the actual velocity of this photon. In other words, the bigger the angular velocity along the z component, the bigger also the angular velocity along the x and the y component, and also the actual velocity. In this table, we can see that the range of the frequency of the electromagnetic radiation, which is photon, is vary from 3 to 3 times 10 to the 20. Gamma ray, X-ray, and ultraviolet photons are ionizing light. In other words, when they hit atom, they can eject electron from it. By measurement, we know that the energy of photon is equal to its frequency times Planck constant. Therefore, the actual photon velocity, which is a function of its angular velocity along the z component, is equal to 11 billion times the square root of the angular velocity along the z component in meter per second. Rule 12. In atom, the total energy of each electron is different, because in contrast to the internal energy of the electron, which is just its rotational energy, the total electron energy also includes the orbital angular momentum, which give an additional rotational energy, and the potential energy of the electron, which is higher when the electron is farther from the nucleus, and which will be transformed into kinetic energy when GP particle attract the electron toward the nucleus. In the atom, electrons are thrown from side to side of the nucleus because the mass of the electron is much smaller than the mass of the nucleus. In other words, the number of the G particle in the electron is much smaller than the number of the G particles in the nucleus. Mass is just the number of G particles that comprise the particle cluster. The GP particle emitted from the nucleus usually just attracts the electron, but at specific location, the GP particle rotation is perpendicular to the electric field, so it's actually a GN particle. In other words, the nucleus can send GP particle that are perpendicular to GP particle, and they are effectively GN particle with specific direction to specific location. This GN particle emitted in low amount to specific locations. When they will hit electron in this location, they will transform it to be in a spin with a specific spin. This and the former rules are the basis for absorption and emission spectra. In a non-absorption process, when a specific photon, here photon 5, collide with electron EU1, this electron is electron spin up, meaning the angular velocity of the z and the x-axis are positive, but it has a specific direction, that's why we call him 1. So when this photon 5, hit this electron, he will change his spin into EU5 and also give him velocity V5 and throw it far from the nucleus. Then GP particle emitted from the nucleus will attract him, and it will be thrown from side to side. When it will reach its original position, it will be collide with GN1 and transform back to its original spin, EU1. But because it has now velocity minus V5, it will transform this GN1 into the photon 5. So the total energy preserved. And this photon 5, will emit it almost immediately into random direction. If this atom is in a liquid or in solid, during the journey of EU5 to its original position, it may emit GE particle from the neighbor atoms in the solid. This GE particle will slow down this electron, and when he will meet GN1 in its original position, it will transform back to EU1, but GN1 will not transform into a photon, because there is no excess kinetic energy. We will call this process black absorption. In this process, the energy of the photon transforms into a kinetic energy of the atom and cause the atom to vibrate because of the GE particle that influence the kinetic energy of EU5. This atomic vibration will cause heat. Blue material absorbs all visible wavelength or visible frequency except blue, and red material absorbs all visible frequency except red. That's why we see a blue material blue and a red material red, because the blue one emit blue photon and the red one emit red photon. That's why if we shine red laser through a blue material, we will see that nothing gets through. But if we shine red laser through a red material, we will see that the red light gets through the material. And this is why green laser will make a hole in red balloon, because the green laser energy transform into a kinetic energy of the atom in the balloons and burn him. And when green laser hit a green balloon, it will be emitted back. In the process in the left picture, a photon, specific photon number 5, hit an electron EU1 and transform its spin into EU5 and give it translational velocity V5. Now, this electron will hit by GP particle emitted from the nucleus and move to its original position. But during the journey to its original position, he will meet GN7 that will transform it into EU7. And because it has translational velocity minus V2, it will transform the GN7 into photon number 2. Because this is not the natural position of this electron, it is not the preferred position. And after some time, GP particle from the nucleus will take him back to its original place. So if it arrives to its original place, he will collide with GN1 and transform back to EU1. But because heat comes from a longer distance from the nucleus, it has translational velocity minus v3. And this translational velocity is an access kinetic energy that will transform the GN1 into photon number 3. So the energy is conserved, and therefore the energy of photon 2 and energy of photon 3 equal the energy of photon 5. So the input was 1 photon and the output was 2 different photons. By this process, we can see that specific photons can transform into other photons and give rise to the absorption spectra that we see here. This black line, for example, can be photon 5. In a fluorescence process, a photon will hit EU1 electron in the atom, for example, and transform it into EU5 and give it kinetic energy V5. GP emitted from the nucleus will attract this electron, and in the journey back, he will meet GE particle from a neighbor atom in the crystal or in the molecule. This GE particle will slow down the electron, but not completely. So now it will have kinetic energy minus V3, which is translational velocity. When it arrives at original position, it will meet GN1 and transform back to its original spin, EU1. Because it has kinetic energy, it will transform the GN1 into photon number 3. But its kinetic energy is minus V3 and not V5. Therefore, it's lower, and therefore it will create photon with lower frequency, photon 3. So in this fluorescence process, we emit photon with high frequency and get photon with low frequency. Some big molecule like specific protein, green fluorescence protein, will have this property in one of their atoms. This GFP protein, originally from jellyfish, can be inserted into any organism, for example the monkey. We see the sky blue because blue photons have higher frequencies than red and green photons. In other words, the blue photons' angular velocity along the Z component is bigger, and therefore they will occupy more space during their precision, and therefore they will collide with more atoms in the atmospheres. When they collide, they will be emitted in random direction, and therefore there is chance that they will reach our eyes, while other photons will just pass without colliding. Because the molecule in the cloud are bigger than the molecule of the gas in the atmosphere, any photon in the visible light will collide with them and will be reflected back to our eyes. But there are less blue and green photons now because they are already collided with the atom in the atmosphere. So we see the cloud red, more red. In stimulated emission process, the atom has some electron not in their original position. Here it's EU5, not in its original position. That's why we have 0 in the brackets. When we emit specific photon into this atom, it will collide, for example, with EU1 and transform its spin into EU7 and give him access kinetic energy V7. Now this EU7 is in the same distance from the nucleus like EU5, and they will send GE particle into each other. That moves them a little bit. Then, GP particle emitted from the nucleus will attract the EU5 to its original position, where it will collide with GN3. That will transform it into EU3. But because it has access kinetic energy minus V7, it will transform GN3 into photon number 7. The other electron, EU7, also will be attracted by the GP particle toward its original position. There it will meet GN1 and transform to EU1 back. But because it also has access kinetic energy minus V7, because like the former electron, they return from the same distance from the nucleus. So it transforms the GN1 into photon number 7. So in this process, we enter one photon, photon number 7, and we get 2 photon number 7. And because this process is very fast, these 2 photon 7 emitted in the same time point and in the same phase. So we got coherent light. With mirror, this stimulated emission process is used to create laser. If we increase the temperature of a solid object, the atom vibrates very fast and the electron can become very close to each other, emitting enormous number of GE particles into each other. These unusually enormous GE particle numbers will move the electron farther away from the nucleus. And two processes can happen. In the process in the right picture, the many GE particles produced by the electrons that almost collide with EU5 because of the high temperature will move the EU5 farther away from the nucleus. GE particle and GP particle can't change the electron spin. They just can't move it. The farther EU5 will be attracted by GP emitted from the nucleus into its original location. There it will meet GN5, which will be thrown away from the high velocity minus V5, but without changing into a photon, because the spin of the electron has not been changed. GN5 will transform into a photon only if the electron has other spin than its original spin that can create GN5 particle. In the left process, the temperature is slightly different, so the electron from the vibrated atom will get less closer to EU5 and emit less GE particles. When colliding, the EU5 will move to this position with velocity V5, and then it will be attracted by GP to its original position. During the way to its original position, it will meet GN7 and transformed into EU7, and because of its velocity minus V2, GN7 is transformed into a photon, number 2. Because EU7 is not in its original location, after a while, GP particle from the nucleus will attract it to its original position. There it will meet GN5 and transform back to EU5, while transforming the GN5 into photon 3 because it has translational velocity minus V3. So in this process, different amount of heat that can be lower or higher from the right process create a different amount of GE particle that move the electron to other location, and two different photons emitted. If we will increase the temperature, more atom will vibrate and the vibration will be bigger, so more electron will move from their original location and more photon will be produced. The most common frequency of the produced photon also increase with temperature linearly by this equation. This is why when we increase the temperature of a solid object, we get light. And this is why when we put gas atoms in chamber and make them move by electric field, we basically increase the temperature. And we get emission spectrum. For example, photon 2 can be the red line in this spectrum, and photon 3 can be this blue line in the spectrum. When a photon passes through a polarizer, one time it can hit the electron in the polarizer, and another time it can miss them because of its precession. And the magnetic field particle from the polarizer electrons can change the photon angular velocity. Fermat principle says that if a beam of light travels from point A to B, it does so along the fastest path possible. Therefore, this equation holds, where V1 and V2 are the velocity in the upper or the lower material, the measured velocity, and A and B are these angles. But light is not smart. The real explanation is the following. When photons move from low density medium, for example air, to a high density medium, for example glass, it will collide with the electron, and this type of collision will throw the electron downward to the photon velocity vector. This is because the collision looks like this, and it's a mathematical truth that I was able to prove. Therefore, the more dense the material, the more electrons the photons collide, and the more the emitted photon will directed downward, and therefore the smaller the angle B will be, and the smaller velocity V2 will be. Therefore, when V2 becomes smaller, the angle B also becomes smaller, like this equation predicted. Because both the electron and the photon rotate with precision, they have frequency, and we can calculate wavelength for them. and also assign a phase for them, which is the initial angular velocity. And because they have wavelength and phase, they will create destructive and constructive interference pattern that fully explain the single and double slit experiment. If we fire separate electrons, one after the other through a double slit, we will still get an interference pattern because they interfere with electron at the edge of the slit. Because the electron has precession, it has also frequency, and we can calculate wavelength for him, and phase. And because the speed of light is constant, the relativity equation also holds, and therefore all the requirement for the Schrödinger equation fulfilled, and therefore the Schrödinger equation hold, and precisely calculate and predict the probable location of the electron in the atom. See the attached book Spheroid Theory of Everything to see how this theory can explain all the chemical property of the element and all chemistry. The major principle in chemistry is that the more electric and magnetic field particle the electron will get, it will be harder to move it, because they will take him back to its original location very fast. Therefore, paired electron, like in this helium atom, will give extra stability, and it will be harder to pull away one of these electrons. The shielding effect is just electrons that emit electric field particles, which are GE, outward. The more proton the nucleus will have, the more GP particle produced, because the nucleus becomes longer and rotate faster. Electrons that are farther from the nucleus get less magnetic and electric field particle, and therefore they are more free to react or to move from their location. Precisely half-full orbital also give extra stability because of symmetry that cause more electric and magnetic field particle being transmitted from the electrons. If we shine photons at increasingly thicker and thicker glass, the percent of the reflected photon create a periodic pattern. In other words, if for one thin glass the reflected was 0%, when we add one more glass, we get 1% reflected photons, and when we add another glass, we had 2% reflected photons. When we add another glass, we get 3% reflected photons, until 16% reflected photon. That we get when we add 16% thin glasses. And then when we add another thin glass, we get again 0% reflected photons. And when we add another glass, we get again 1% reflected photons. And another glass adding, we get 2% reflected photon, and so on until 16 again. And then again 0 reflected photons. This periodic pattern created because the electron moved to different energy level and different shells when we add more and more glasses. And because the angular velocity of the electron and the proton is preserved, the electron movement to different shells and different energy level will create a pattern that repeats itself. If we change the photon frequency, the thickness of the glass that required for 0 reflected photon will change, but the pattern will repeat itself. When we shine light into a mirror, like in the bottom picture, each part of the mirror will reflect the light, but the reflection from specific distances will cancel each other out. That is why when we remove specific mirror from the big mirror, in other words, when we remove specific line in the mirror, we can remove the specific mirror line that cancels the other one, and we will get more reflection. If an atom moves very fast downward, like in the upper picture, the distance that GE particle will have to travel in order to reach the proton will increase. But because the measured speed of light is constant, in other words, the time that required for all the GE particle emitted from the E particle to clean the distance to the proton from the disturbing G is constant per unit length, the time that take the GE particle to reach the P particle will increase. In other words, when the atom moves very fast, the time interval between two GE particles at reaching the proton will increase. and therefore if an astronaut will move very fast, it will age slower. We call this process time dilation. If we accelerate proton at particle accelerator very close to the speed of light, the mass of the proton will be increased 11,000 folds. This is because at high speed, the proton will collide with G particle sometime at the edge of it, and they will be inserted into the proton a little bit, so its mass will increase. In other words, the proton will collect many G particles during its pathway. If we accelerate two protons like this in the opposite direction and they will collide, they can create a particle that is 22,000 fold heavier, because they can collide at the edge and insert a little bit into each other. That is the reason that particles that formed in particle accelerator are not stable, because of this rotation that can become close to an intermediate axis rotation. In other words, the protons that insert many G particles along the way and increase its mass 7,000 fold will now have rotation about an intermediate axis and will become not stable and break very fast to other particles, which are smaller. In photon entanglement process, we shine blue laser into a nonlinear crystal. One of 10 billion photons will be splitted by the crystal into two photons with equal energy, which is half of the incoming energy of the photon. The momentum is also conserved, therefore the translational velocity of the splitted photon will be in opposite angle from the incoming laser vector, and their spin will be opposite. 1 of 500 of these paired photons will be entangled. If we couple these photons into optic fiber, we can take them anywhere, and then we can measure their polarization. We will see that the measurement of one of these photons will affect immediately the other photons. This effect is speedier than light. The mechanism underlying this property is the following. In step 1, the blue laser photon collides with the crystal nucleus and at its edge and breaks some G particle from its cluster. This photon loses half of its energy and transforms from photon 2 to photon 1, and one of the breaking G particle will receive the other half energy and become also photon 1. In the next step, the nucleus collides with one of the breaking G particle and send it in the direction of the former photon. In the next step, this former photon moves through polarizer A and hit the electron in the detector A. The G particles that move after him will have a clear path because he is right after him. So in the next step, this detaching G will hit the electron in the detector and will fly back all the way to the nucleus, and from there, after colliding with the nucleus, into polarizer B to influence the second photon. During the pathway to polarizer B, this detaching G will also have clear path because it flies right after the other photon with a speed that is the actual speed of light, which is much higher than c, and we can regard as infinity for this system. When a photon is absorbed, the received electron will be more time farther from the nucleus in the direction of the photon, so it will attract the nucleus to this position. When a photon is not absorbed, the received electron will go almost immediately back to its natural place, so the nucleus will not change its position in space. In Doppler laser cooling, we adjust the frequency of the photon of the laser to be just slightly below the frequency that is absorbed by the specific atom that we want to cool down. So only if this atom will move toward the laser, it will absorb the light, and then it will slow down, because it will see it blue shifted. See blue shift process. Rule 15. The magnetic force on a charge that moves through a magnetic field is given by QV cross B, where Q indicates the number of charge, and it will be negative for electron and positive for proton, or positive charge. B indicates the number of the magnetic field particle traveling in this field, and v is the velocity of the charge. This rule can be visualized by field interaction of rule 4a and 4b. But direct visualization is harder because it involves two steps. Because a moving charge creates a magnetic field by rule 4a, and a magnetic field will change the charge spin by rule 9b. Therefore, the correct way to prove and understand this rule is to use my simulation. When a current, which is a charge movement, flows around a circular loop, the magnetic field of the moving charge will end up in the center of the loop and will make a really strong magnetic field in the center of the circular loop. In a solenoid arrangement, the moving charge also creates magnetic field, but because of this arrangement, some magnetic field will cancel each other out, and other magnetic field will add up. Therefore, the total magnetic field of the solenoid is like in this picture. We can see that the magnetic field is concentrated into a nearly uniform field in the center of the solenoid, and the magnetic field outside is very weak. Inserting an iron core will increase the magnetic field strength hundreds of times. When a magnet is moving toward a conducting ring, the electron in the conducting ring will feel a force by rule 15. This is the x component of the magnetic field, and this is the relative velocity of the electron. Therefore, the created force will cause this current around the loop of the conducting ring. When a magnet falls through a copper pipe, it will slow down, because the electron in the copper pipe will also feel a force by rule 15 and will create current around the cross-section of the copper pipe. This current will create magnetic field that will oppose the movement of the magnet. Property 16. Superconductor stay locked in space when put near magnet. Explanation. In superconductor, the temperature is very low. We have to cool it with liquid nitrogen, so the atom don't vibrate and the free electron can move without colliding with other electrons. So if we place it next to a magnet, if the magnet will move, a strong current will flow immediately in the superconductor to oppose that movement, by creating magnetic fields that attract or repel the magnet to oppose its movement. See former property. Therefore, the relative motion will be cancelled, and the superconductor will be locked in space. But the superconductor can move on the magnetic rail or to rotate about a round magnet, because in this movement there is no change in the magnetic field. When the electron and the proton collide with G particles that are moving in all directions and in any orientation, they transform them mainly into the electric field particle Gp and Ge. This is because the angular velocity along the y component is the highest. But because they also have tiny angular velocity along the x and the z axis, they will also create few magnetic field particles, which are Gn and Gs, and very, very few gravitational field particles, which are Gl and Gr. This particle rotates perpendicular to Gp and Ge particle and also to Gn and Gs particle. This gravitational field particle will attract both the electron and the proton, or any nucleus. Because like the electromagnetic force, the gravitational force is also mediated by particles, it reduced by r squared. But the gravitational field is much weaker than the electric field, and for each 10 to the 36 electric field particles, only one gravitational field particle will form. When the gravitational particle will hit a photon, it can attract it or repel it because it's very light particle, depending on the collision point. In gravitational lensing, we see only the photon that get attracted by the gravitational field particle. A black hole is just a huge nucleus that rotates very fast in the directions that create a lot of gravitational field particle. Therefore, it attracts other atoms and particles and continue to grow by inserting them into the edge of its rotated structure. The farther the galaxy is from Earth, the faster its movement away from us. This property created by the following mechanism. Step 1. Many years ago, there was a huge black hole that attract a lot of stars, which attract a lot of planets, and grow into huge sizes. Then its rotation become rotation about an intermediate axis, which is unstable, and therefore it explode, or break apart to many pieces. This explosion is what we call the Big Bang. Therefore, around the location of this Big Bang, there are a lot of material. In the next step, after this big explosion, galaxy formed. The farther the galaxy from the Big Bang center, the more closer to the old material, which was around the black hole, and the more it will be attracted by this old material. Therefore, the more it will accelerate away from the Big Bang center. And because when we look at other stars, we see just the relative velocity, we see that all the stars accelerated away from us. CMB, cosmic microwave background radiation, or photons, glow the same in all directions and not associated with any object. These photons were created by the following mechanism. Step 1. Immediately after the Big Bang, there are no atoms, so any created photon will disappear by collision with the electron or the proton, or by going outward. Step 2. Hydrogen atoms formed and are close together. The temperature in this step is 3000 Kelvin. So by their collision, they will form photon with wavelength of 10 to the minus 6. See property 28 and this formula. This photon now can jump from one atom to the other and to preserved. Step 3. Hydrogen atom clouds thrown farther from the Big Bang center in all directions, and the distance between them increased. So there will be less collision and less creation of this specific photon. Step 4. This photon goes back and forth between Earth and the hydrogen cloud. But because these clouds are located farther from the Big Bang center, their velocity is higher, and the wavelength of the photon that is thrown to Earth become longer and longer each time. So now, 13.8 billion years later, we see the wavelength of this photon as 10 to the minus 3 in the microwave region. So the space doesn't stretch. And this is the explanation for this huge redshift. Neutrino and antineutrino are just pieces of G particles that break from the nucleus during positron emission, electron capture, or beta emission. The neutrino cluster contains 232,000-fold less G particles than the electron cluster. And its angular velocity along the Y component is 0, therefore it has no charge. And it's almost undetectable. But it has angular velocity along the X and Z components, so it has spin. The neutrino travels at the speed of light and is a left-handed particle. In other words, its spin always pointing in the direction opposite of its velocity. In the other hand, antineutrinos have their spin parallel to their velocity. This left or right-handed characterization is not meaningful for other particles that don't travel at the speed of light, because they will be seen left or right-handed by someone who travels faster in their or in opposite direction. The observer always sees the same spin, but it will see opposite velocities. But for neutrino, any observer can travel faster than light. This property of the universe gives us good evidence that this theory is correct, and any opposite charge or antiparticle is just rotated oppositely. This is summary of the particle structure. This is summary of G-based particle properties. This is summary of E-based particle properties. This is the list of the rules that this theory is based on. These are just collision rules. I proved the first three, and I hope that you will prove the rest. I color in brown the rules I've reviewed in this video. To review all the rules and all the property of the universe, download the book Spheroid Theory of Everything from the description. This list is for the property of the universe. This theory explains all the property of the universe. To see the blue properties that I didn't review in this video, download the book mentioned.